now continue with understanding delimiters. Delimiters are characters used to separate smaller parts of the program from one another. These small parts are called tokens. A token is the smallest complete C language element. A token is either a single character or a sequence of characters predefined by the C language, such as int or return, or a sequence of characters, words defined by us, so defined by you, which we will then also learn about later. When a token is predefined by C, it cannot be used except in a prescribed way. So the way of the use is previously determined. Those tokens are called keywords. For keywords we have already encountered include int, main, and return. We will still see many other throughout the course. Now there are three types of delimiters that we will explore here. Single delimiter, so backslash also, but semicolon or space. Paired symmetric delimiters, you see them here. Asymmetric delimiters that begin with one character and end with another one. Each of these has a specific use. Most of them have unique, unambiguous use. That is, when you see them, they can mean one thing and only that one single thing. Others have slightly different meanings when they appear in different contexts. In our Hello World program, there are only two required space characters that are delimiters. We see a delimiting space here between int and main, and we also see a delimiting space between return and the 0 value. In these cases, the space character is used to separate one keyword or token from another. A keyword is predefined word that has a specific meaning. It is reserved because it cannot be used elsewhere for some other meaning or purpose. Int, main, function, and return are all keywords and tokens. 0 and semicolon are tokens. One is a literal value and the other is a delimiter. The compiler identifies and translates tokens into machine language. As appropriate. Delimiters, including space, facilitate interpreting text in the program compilation stream into tokens. Otherwise, when spaces are not needed to separate tokens, they are optional and are considered as white space. You can see the paired symmetric delimiters from the list of types of delimiters. One always begins a particular sequence and the other always ends it. So you see here, this one is used for the specific type of file name, which tells the compiler how to search for the given file. The next is parenthesis, indicates that the token is associated with a function name, and the next is the curly bracket that indicates a block that groups one or more statements together into a single unit. We will explore that statement again. Finally, we have the quote mark, indicates that the beginning and the end of the sequence of characters also referred to as a string. Now we also consider the first line that starts with sharp and ends with a new line. This is an asymmetric delimiter pair. This particular line is the preprocessor directive. So don't forget, this is the preprocessor directive. The preprocessor is the very first part of the compiler phase where directives are interpreted. In this case, the file name stdio.h is searched and inserted into the program compilation stream or included just as if the file had been typed into our program. To direct the compiler to insert it, we only need to specify its file name. The compiler has a predefined set of locations to look for it. The compiler finds it and opens and reads it into the stream. If it can't find, an error is reported. Now, this sharp include mechanism allows a single file to be used instead of manually copying the contents of this file into each and every source file that needs it. If the stdio.h file changes, all programs that use it can simply be recompiled to pick up the new changes. Otherwise, any changes to any version of the copied text of stdio.h would have to also be in every file that also copied its contents directly. Too much complicated. So that's why I use just simply sharp include. We will encounter many of these kind of files, those that are part of the standard library and those we create by ourselves as we begin to make our programs more complex and useful. Now, with our understanding of delimiters, we can remove the extraneous spaces, tabs, and new lines. We can pare it down to just keywords, tokens, and delimiters. Our program, hello new white space C, would look like this. You see that? And that also would run the same way like we have just run it before. Now, is it a good programming practice? Obviously not. Never. You might think that a practice like this would somehow save space on your computer's hard drive or SSD. In the reality, the space saving is insignificant, especially when compared to the added human time needed to understand and modify such a program. It is a basic fact of programming that programs are read many times more often than they are created or modified. In reality, every line of code is read at least 20 times over its lifetime. You may find that you reread your own program several times before you consider changing them or even reusing them. Others will read your programs with or without your knowledge. Therefore, while we pay attention to the rules of the compiler and strive to write complete and correct programs, we also strive to write clear programs for other humans to understand. This not only means using commands effectively, but also using white space effectively. Now, note that we do not remove the space in our string message, right? Okay. So, when a space or new line character is not required to delimit a portion of C code, it is considered white space. And white space yep, can also be tab, carriage return, and some other obscure characters. However, the use of tabs in C source files is discouraged since the program listing may look different on someone else's computer or when the source code is printed, thereby diminishing clarity and obfuscating your original intent. There you go. Now, always use spaces instead of tabs in your source code files. There are many options by as many programmers on how to effectively use whitespace. Some programmers feel strongly about using two spaces to indent a line, while others are vehement about using four spaces. Others don't care one way or the other. In reality, there is no one correct way to do it. As you write more of your own programs and read those of others, you should pay attention to whitespace styles to try to get a sense of what is effective and what you might prefer by yourself. Consistency in code formatting, including whitespace, is more important than you might think. Consistent code helps set the code reader's expectations, making the code easier to read and hence to comprehend. Inconsistent whitespace formatting can make the code harder to read and consequently introduce coding errors and bugs. Here is an error example. So here is an example, and it does the same hello world, but yeah, it's really nonsensical and inconsistent. Note that this is still the valid C program we had before. It will compile and run and provide the same output, so hello world, as before. The C compiler ignores the white spaces. Because this is an example of bad practice, you do not have to type this in yourself. In the remaining programs, here, all source code will be presented with both consistent white space usage as well as a consistent commenting style. You don't have to adapt these stylistic guidelines, but you should pay attention to them and compare them to other styles. Whatever style you choose, apply it consistently in your own code. Okay, now here's a table of delimiters that we have already encountered in our simple program. Curly bracket, angle bracket, hash, okay, double forward slashes, new line, so again, angle bracket, hash, and also double quotation mark. Now we will see later that some of these punctuation marks have different meanings when used in different contexts. When their use is not as delimiter, the alternate meaning will be clear from the context. For instance, an angle bracket opening is the less than logical operator and will occur alone when it has the meaning. So for completeness, we have included the delimiters to indicate an array, which is a square bracket. Okay, and we can continue with introducing statements. Statements in C are the basic building blocks of programs. Each statement forms a complete unit of computational logic. There are many types of statements, and they are made up of wide variety of elements. Simple statement, as you see here, is for example return 0 semicolon. Block statement begins always with a curved bracket and also closes with a curved bracket. They contain a group of other statements. Here we represent them as this: curved bracket open and then curved bracket closed. We represent one or more statements of any type of valid statement. The next one is complex statement. This consists of a keyword and one or more block statements, like main, which is a complex statement. It has the main keyword and other predefined elements, including a block statement. Compound statement. These are made up of simple statements and or complex statements that consist of multiple statements. The body of our program is a compound block statement that consists of two statements: a call to printf function and the return 0 statement. In our Hello World program, the following are the kinds of statements we have already seen. Now, in our Hello World program, the following are the kinds of statements we have already encountered, as I mentioned. Preprocessor directive. So this begins with the hash and ends with new line, or sharp and ends with new line. It isn't really a C statement that performs computation instead. It is a command to the compiler to process our C file in a specified way. Preprocessor directives do not follow C syntax and formatting, but they are included in the language. We can think of them as outside of C syntax. They direct the compiler to do extra preparatory stuff before the compiler gets down to the actual work of compiling the program. So, preprocessor directive. Function statements. The main function, which is where our program begins executing, is really predefined. So it's a predefined name for a more general function statement. By adding statements to main function, we define our program. Every executable C program must have one and only one main function defined. It is a complex statement. We will also define our own function statements, or more simply stated, our own functions. Function call statement. This is a simple statement. Just as main function is called by the system to execute, we can call functions that have already been defined or that are defined in our programs. In this case, we call the predefined printf function to do some of the work for us. When we call a function execution of the current statement of the current function is suspended, and the execution jumps into the called function and continues in that function. Return statement. This is a simple statement that causes execution in the current function to end. Execution that then returns to the caller. In the main function, when return is encountered, Our program ends and control returns to the system. The next one is the block statement. It's a compound statement that consists of one or more statements enclosed in curved brackets. Block statements are required for function statements and control statements. We will call these named blocks and have a well-defined structure. Yet, we can also group statements together into unnamed blocks to organize multiple statements into related units of computation. Unnamed blocks have a simple structure and can appear anywhere that a statement can appear. For completeness, here are other statement types that we will encounter later on. Control statement is the following. This includes if curved brackets, else curved brackets, or go to and break and continue. These are control statements. The return statement is also a control statement, like a call statement function. These change the order of execution of statements within a function. Each has a well-defined structure. Looping statements. These include while, do, while, and for. They are similar to control statements, but their primary purpose is to iterate, that is, to perform a statement 0 or more times. We will look at this later on. Expression statements we will also look at later. These are simple statements that evaluate expressions and return some kind of result or value. Except for control looping and the wide variety of expression statements, we have already encountered the essential C program statements that make up the bulk of our C programs. Let's look more for more. Introducing functions. Now, functions are callable segments of program code that perform one or more statements of related computational work. Functions group statements into a cohesive set of instructions that perform a specific complex task. This may comprise a single statement, only a few statements, or many statements. Functions can also call other functions. Functions made up of one or more statements are the next higher up, more complex units of a program composition. Statements make functions, functions make programs. Indeed, the main function is a function made of statements and other functions. The process of writing programs, or also solving a given program with computer program, is primarily the task of breaking the problem down into smaller pieces, so into functions, and focusing on the work to be done in each smaller piece. When we break a problem down into smaller parts, we can more easily see the essence of the problem. We can focus our attention either on aspects of the larger problem or on the fine details of subdivided problem pieces. We may be able to reuse a single problem piece or function so that we don't have to copy and paste it throughout the program whenever it is needed again. Anytime a function changes, we change it in only one place. If we discover that a function does not cover all the cases we originally expected, we can either expand its functionality or add a similar function to provide a slightly different solution, or further break the function down into smaller functions. Now, this approach is preferable to writing one large program without any functions. In many cases, writing a monolithic large programs without functions can and has been done. However, each time a program like this would require modification, it would have to be understood in total, so that even a small change might require the entire program to be considered. When the problem can be expressed so that we can see its major and minor parts as implemented in the functions, it's most often easier to understand it generally and its components easier to modify. So, understanding function definition is the next level here. Functions therefore are essential to part of any C program, and each function that you will create has the following parts. You see here function identifier. This is the name of the function. The name of the function should match closely to what it actually does. As for the next one, function result type or return value type. Functions can return a value to the caller. The caller may ignore the result. If the return value type is specified, the function must return a value of the type of to the caller. Function block. A function block is a block directly associated to the function name and parameter list where additional statements are added to perform the work of the function. Return statement. The primary mechanism to return a value of the specific type from the called function to its caller. Function parameter list is an optional list of values that are passed into the function which it may use as a part of its calculation. Now the goal is for you to begin to recognize, understand, and be able to create a function statement pattern for yourself. We will use an absolute minimum C program with main as our example function and highlight each essential part afterwards. A function type, function identifier, and a function parameter list comprise the function signature. So once again, function signature is made of function type, function identifier, and function parameter list. In a C program, each function identifier must be unique. In other languages, the complete function signature is considered, but not in C. When a function is called, only its function identifier is considered. That is the name. Once the function has been defined with a function identifier, that function identifier cannot be redefined with a different function result type or function parameter list. Each function identifier must be unique in C. Note that the function signatures are not used in C to uniquely identify a function. Therefore, two functions with the same identifier but the different parameter list or result types will cause a compilation to fail. As for the next, exploring function identifier. So main is a function just like any other function. However, it does have some significant differences. The main function identifier is reserved. The signature for it is also predefined in two specific ways. So you cannot name any function in your program as main, and you can never call main itself. Main can only be called by the system. Function identifiers should be descriptive of their purpose. You would expect a function named creating to print greeting. Well, we already talked about that function identifiers are case sensitive. This means that a lowercase main and a uppercase main and sentence case main are different function names. And when two functions have a similar purpose but are slightly different, do not rely on differences in the upper lower case of their names to differentiate them. It is far better to make them slightly different in length or use different modifiers in their name. Two common methods to make function name descriptive yet easy to read is the camel case and the underscore separated, and also known as snake case. Camel case names have the beginning characters of words with the name capitalized. In underscore separated names, underscore is used between the words. So here you have it. All lowercase, so make light green, make medium green, and so on. Camel case, make light green, make medium green. This is it. And this snake case, the underscore separated. You see that as well. As you see, the all lowercase names are somewhat difficult to read. However, these are not nearly as difficult to read as all uppercase names. So please don't use all uppercase names. The other two ways are quite a bit easier to read, therefore it is better to use either of the last two. If you choose one identifier naming convention, stick to it through your program, so don't change. So if you make all lowercase, then completely take only all lowercase in your program. Do not mix different identifier naming schemes, as this makes remembering the exact name of the function identifier as well as the other identifiers much more difficult and error prone. Now, if you explore the function block is where the work of the function actually happens. Within the function block are one or more statements, as you see here as well. In the hello world main function, there are only two statements. Main basically, and the return statements. While there is no ideal size, large or small, for the number of statements in function block, typically functions that are no longer than either the number of lines in a terminal, so 25 blocks, or printed page, say 60 lines, are preferable to much longer functions. Okay, so make your function relatively short. In some cases, longer functions are warranted. Rarely, if ever, are they considered good programming practice. Okay, so not at all. Now, as for next one, exploring function return values. A function statement can return a value to its caller. It does so from within its function block. The caller is not required to use the return value and can ignore it. Hello world, the printf function or call actually does return a value, but we will ignore it. When a function statement is specified with a return type, then it must return the value of the type. So, such a specification consists of two parts: the return type of the function given before the name of the function, and the return value, which is of the same type as the return type. In main, C or int, short for integer or whole number, is the type specified that the main function must return to its caller. Immediately before the closing brace, we find the return 0 statement, which returns a 0 integer value. In most OS calls, a return value of 0 by convention typically means no error is encountered during compiling our file. If the return type of a function is void instead of int or some other type, there is no return value. The return statement is optional. Consider the following two functions. Here you see void and there is no return value. Now, in the following program, hello2 C return is expressed explicitly. Let's see that. Let's try to shape our file accordingly. So we will do void print comma and print f comma semicolon and return semicolon, and we've got it. Now what we do here in main, print f hello, then we continue print comma, and then here we do world and here I need to change it to add the space as well, and I think we are done. So this time I'm taking this as hello to C, so let's save it. And let's hope that it runs well. Yeah, I got it. Here you got it. So it runs well. I also can make a check on my CMD if that would work correctly. Hello to C and hello to exe, and now let's do hello to, should work fine. No problem happened, so we can return to our presentation. So in the hello2C program, we have a function whose purpose is only to print a comma and space to the console. Type out this program, so just as I did, compile, run and verify it. Verification should be familiar now since we are creating the same output. Clearly, by itself, this is not particularly useful function. Yet, our intent is to focus on moving from a single statement in our original Hello World program to a program that employs a number of functions to do the same thing. In each case, the output will be the same. And as we expand our knowledge of C, our functions will become more useful and more relevant in the future. A recent development in C is that return 0 semicolon is optional. If there is no return semicolon or no return 0 semicolon statement, then the value of 0 is assumed to be returned by the function. This, by convention, means everything is executed normally and all is well. With this in mind, the modern minimal main function now becomes like int main parenthesis curved bracket, and return is not necessary. It became optional. The previous main function becomes as following. Yeah, you see that? And then we can continue now with the passing in values with function parameters. A function can be values given as input to the function. It can then use them within the function body. When the function is defined, the type and the number of parameters that can be passed in or received by the functions are specified. When the function is called, the values of the parameters are given. The function call parameters must match the type and number of parameters specified. In other words, the function signature must match both the caller of the function and the called function. So here you are. In other words, the function signature must match both the caller of the function and the called function. Okay. Now we have already seen a printf. Yeah. Okay. And then function parameters are specified in the function definition between the two parentheses delimiters. The ellipses indicate that there can be 0 or more function parameters in the parameter list, separated by commas. A C token we haven't yet encountered, so the comma itself. When there are no parameters, the definition look like here: void, or shorthand just point void, and the parentheses and are equivalent to empty parameter lists. And now each parameter consists of two parts: a data type and an identifier. The data type specifies what kind of value is being used: a whole number, a decimal number, a string, and so on. And the identifier is the name used to access that value. Multiple parameters are separated by a comma. We will explore data types fully later on. Value identifier is very similar to function identifier, where a function name can be called from somewhere. The parameter identifier is the name by which the passed in value can be accessed within the function body. Yep, within the function body. Okay, now let's look at what parameter lists look like with 0, 1, or 2 parameters. So 0, 1, or 2 parameters. Take as given for the moment that the C type of the string passed into the function is char star. This will be later on introduced. Okay, within the function body, the parameter can not only be accessed but can also be manipulated. Any such manipulations on a parameter value are only valid within the function body again. Once the function body ends, the parameter values are discarded. In the following program, we can see how to use the parameter values within the function body. Here you see. And in the next one, now these two functions, so we can use again. Here we go. Sorry. Oops. Yeah. So now with these two functions which we have here, we can use them to build a more general greeting function that takes a greeting and the addressee. We also could then call this function with two values one value for the greeting and the other for who it is being greeted. So first, let's actually create this hello 3 file. That is, we change this. I take the content, I make a new file, and I just simply copy paste it first. Then void here, and void. We continue with void print word star word. Let's hope that it would work. Fine. Print. Oops, where is it? Word and semicolon. And now we use here print word hello. Word hello. Then print comma. And print word world. And as for the last one, print f. Exclamation mark and backward slash n and semicolon, and we're supposed to be alright. This time I'm going to save it under hello 3. Hello 3.c, and let's see if that would work correctly. And here we have a problem. Let's see what's that. I believe it's a return. Let's try to run it. No. So I myself did not recover what the problem was, so I completely rewrote the entire program. Once again, let's do it together as well. If that can happen, that can happen. Let's see what's wrong. So let me check. It's immediately. So here we are. I had actually here void. Let's try to run it as well with void. Also runs well, no problem. So with or without void, it runs well. Okay, now let's try to repeat it, and let's see what's wrong. As I said, so void print comma. You can add the void if you want. You don't need to. And then printf, and please enter a comma and then a space, and that's it for this program. Actually, you can copy paste this part, make the next print, so print word, and this time you add char star and word, and you continue with printf, and this time you have to change this to s, and a comma word, and you're done. You can continue with the int main. So print word, this time hello, and semicolon to the end, then print comma, nothing, void is it, right? Then the next one is again print word, but this time you use world and print f. As you remember, we had the exclamation mark and n, and then basically here semicolon and return 0 semicolon. Now let's try to run it, and there is no mistake this time. It works fine. As I said, I don't know why it didn't work fine. It works no problem, no serious problem, and I guess it would work also under our GCC. So let's take a look. Hello 3, whether it works fine, and yes, it does work fine. So we can continue our work with the slides. Okay, in the two functions defined because the return type is void and the return statement is optional or omitted, we can continue now. As I mentioned, let's do the following. This is now this time hello 4C, and we have much more to do. Let's also do that as it says here in our explanation. Okay, so the next code, what I need to do is void print greeting, and here car greeting car address C. We continue with the next. So print word greeting then semicolon print comma semicolon, and again print word, this time address C. Okay, should be fine, and we got our print f here, which we take here this time. Also good. And now let's do work on the main, and let's see what we have here. So int main print greeting, take this here and use hello comma world. Then as for the next one, print greeting again, good day, your Royal Highness, your Royal Highness. Then next one, again print greeting, we continue. Howdy. Joan, Q, and Q and Jane P. Dowie. The next print greeting goes like this. Hey, Moe, Larry, and Joey. We get rid of this here, and let's see if that would work again. So save as this time, and we turn to hello 4 this time. saved, so let's try to run it, and hopefully it works without any mistake. And voila, this is what we get. That should be okay. Let's also check here if we have done our work fine. Then hello 4 would be okay. And yes, you see it works fine. No mistakes, no problems are reported. Okay, so passing values in with function parameters, we still continue. Wow, that's a hard job this time, but not much more to do. Now, we have moved the statement from the body to of main into a newly declared function print greeting. You have seen that, which takes 2 parameters of a string type. We have a function that can be called with different values, which we saw in the main body. So print greeting was a function. It's called 4 times, each time with 2 different string parameters. Right? Yeah, and this program can be also made more simple. And the simplification goes in the way that we get rid of a few functions, and we create this print greeting in a different way. So let's see that. Let's take this out. This print word, print comma, we don't need them. So for the next, what we need, we saw here, right? So let's get back here. Who, right? And let's create it. Who, and all these things disappeared this time. And we just have print f the following. So s, so string, one more time, string value and the new line, and then comma greeting who, and the semicolon. Int main should be okay. It says, however, this time let's do greetings, and howdy is fine, but here hey, Mo, Larry, and Curly should be okay. Hopefully it works fine. Let's check it. Now this time also we got it correctly. As for now, let's move to the next as well here. And I'm doing here hello 5 C and hello 5 exe and hello 5 I tried to run. No problem reported, so we can assume that the compiler made the job very well and I did not make any mistake.